So welcome to the June Orion meeting. I'm Don Spalding, the president, and Orion is an organization that tries to promote astronomy and science in the East Tennessee region. Tonight we've got a presentation again by Kevin Wilson, who was good enough to give us a nice talk last month. And this month he's going to talk about the ancient Mesopotamian astronomical texts, which sounds like quite a different approach to astronomy than we usually have, but should be very interesting to hear about that. So,
all right. Thank you, Don. Yes, I was quite surprised to be asked back to speak again this month. I've now attended 3 Orion meetings, and this is the second time speaking. And most people generally find that I'm best in small doses, so 2 months in a row may be too much. But this month I'm speaking on ancient Mesopotamian astronomical texts, which is actually much more in my wheelhouse than spectroscopy is, because this is what my PhD is actually in ancient Near Eastern studies. So I should be able to make up much more convincing answers than I did last month. So now we're going to be looking at the area of ancient Mesopotamia, which is kind of the dark green area you can see here. It's the area of modern Iraq and a little bit of western Syria, and also Kuwait and some others down here. Mesopotamia is where the earliest civilizations in the world emerged, and also the first where writing emerged, although Egyptologists might disagree about this. Mesopotamia comes from meso, meaning middle, as in Mesoamerican or mezzanine, the middle tier of the balcony. Potamia, we only have one other cognate word from that in English, which is hippopotamus. Anyone know what hippopotamus means, where the name comes from? Yeah, it's a river horse. Hippo is a horse, and Potamia is a river. Mesopotamia means the land between the rivers. And in this case, it's the Tigris River that flows to the south here, and the Euphrates River that flows from up here is joined by the Khabur River and comes down. Mesopotamia is divided into 2 regions. You see this point where the 2 rivers pitch together pretty closely. That's been historically the dividing line. The area to the south is called Babylon. And then to the north, we have a larger area called Assyria. And these were some of the earliest civilizations. Down at the southern half of Babylon was known as Sumer, and that was, in fact, the earliest civilization and language that we know about.
Can you put more or less a date on the period that you're discussing?
Ancient East is normally dated from around 3300 BCE down to, we'll say, around 300 when Alexander the Great is wandering around. If you're not familiar with the dating system, BCE means before the Common Era. Era meaning time period, not mistake. And it's simply, BCE means the same thing as BC does. CE means the same thing as AD does. But it's a non-sectarian way. I mean, if you say BC and AD, that kind of presumes Christianity as the reference point. And BCE and CE are generally used in scholarly contexts. So we're not excluding people. Yes?
But most of what you're going to be telling us about is Babylonian and Assyrian, which is,
right.
They've had writing for about over 2,000 years.
Yes. Well, the earliest texts in the ancient world are from around 3300 in Sumer. As you can see here, the 2 main languages in this area, and they're really historically distinct periods. These didn't overlap. Is you have Sumerian, which first emerges around 3300, and this is an example of a Sumerian text. It's actually a tax receipt. The earliest documents that we have are business documents and tax records from ancient Sumer. The other language is Akkadian, and we start getting languages in Akkadian around 2500 BCE. Akkadian is a Semitic language, which means it belongs to the same family as Aramaic, Hebrew, and Aramean, or Aramaic and Arabic.
Do you distinguish between a written language and hieroglyphics?
Well, some of hieroglyphics is written, but it's simply a closer to a pictographic language. And as you can see, there's a lot of pictographs here in Sumerian, and a lot of these signs began as pictographs.
But the hieroglyphic languages preceded?
They didn't precede, they arise at about the same times. We start getting old Egyptian texts somewhere around the beginning of the 3rd millennium BC. Yes?
Sumerian was developed in Sumer, which was down in the lower right.
Correct.
Akkadian was developed in Akkadian.
It's called, yes, it comes from Maine. Akkadian is called Akkadian because the first texts that we found were found at the city of Akkad. And so we didn't know about these beforehand, so we named it after the first city where we found them.
So were Sumer and Akkad pretty far removed geographically, so they didn't overlap and there wasn't a lot of sharing while they developed?
Akkad is down in this area, and Sumer is down in this area, so they were fairly close. And a lot of the writing signs are quite similar.
So there was some.
There was a lot of overlap. It's just Sumerian was not an Akkadian language. We don't know what family it belonged to because it was the only one of its kind, so we have nothing to compare it with. Although I actually once attended a lecture where someone was making the case that Sumer was a pidgin language. A pidgin language is a combination of two languages, like Creole is a mixture of French and a native language in English. But I don't know how you know if something is a pidgin language if it's the first language in the world. You know.
It should be the first one we have like samples of or something like that.
Right, yeah. So, Akkadian is divided into two dialects, Babylonian, which is southern Akkadian, and Assyrian, which is northern Akkadian. And they were probably mutually understandable between them, that if you spoke Babylonian, you could talk to someone who spoke Assyrian. There were some differences in endings, and the writing system was somewhat different. The writing system is known as cuneiform, and it was created by taking a clay tablet that's wet and using a reed, like a long stalk that you've cut across it, and using that face to press into the tablets at different angles. So you can see some of that in this text. These are made with the reeds, and these are as well. We get into true cuneiform when we get into Akkadian, and you'll see closer images where you can tell that they're actually just pressed in. But it's a very complex language, and you need to know several hundred different signs in order to read Babylonian. It was not a simple writing system. Gave me headaches trying to learn it, and I had flashcards. And one of the problems is that each sign often has a meaning, that what it means when it's by itself. It can also have a meaning as a determinative, meaning it tells you what type of word the next word is. For example, if the next word was a man, you would have the word man in front of it as a determinative, but it wouldn't have been spoken. And then they can also have syllabic meanings, often more than once, like ba, or na, ta, tu, te, all those different syllabics. So you have to learn about 5 different things for each letter you learn. The dictionary is a hell of a thing. Now, there's a few things we want to keep in mind before we start. One of these is the fact that some things have changed since the Babylonians were doing astronomy. The axis precesses on a 26,000 year cycle. And the practical aspect for astronomy is that this moves the direction of the vernal equinox. The vernal equinox was in Aries, which is about 51 degrees east of where it is now. Back then it was quite a bit different. They also had an astronomer's dream conditions in that there was very little light pollution. I mean, there's only so much a torch can put out. They had a lot fewer clouds because they were in an arid environment. Although they did have to contend with dust storms, which most of us never have to deal with. The latitude of Mesopotamia, it lies between about 31 to 36 degrees north. In Tennessee, we're at roughly 36 degrees north. So they would have seen roughly the same sky that we see at night, with perhaps 5 degrees more to the south. And fourth, and most confusingly, their calendar is different than ours. They used a lunisolar calendar. If you're not familiar with the lunisolar calendar, we use a solar calendar. Our New Year's starts when the Earth returns to the same place it was at the previous New Year's, and we keep it that way. But the Babylonian calendar was based on the lunar cycles. So you had a month start every time you had a new moon. And because it takes roughly 29 and a half days for the moon to go around the Earth, that means you get you get months of either 29 or 30 days, depending on when they're able to see the moon at that point. And the problem is we have more than 12 lunar months in a year, but we don't have 13 lunar months in a year. And so you're going to lose about 2 weeks each year if you're on a lunar calendar, if you go 12 months and then start over. And the way they dealt with this was by adding what are known as intercalary months. If you're not familiar with the practice of intercalation, it's the practice of adding days or months or some other time period to a calendar in order to keep it in sync, usually keeping it in sync with the summer calendar. So there are some calendars still today. The Arabic calendar does not add intercalary months, and it's lunar based. And so, you never know when Ramadan's going to come around because it shifts by 2 weeks every year. The Jewish calendar, like the Babylonian calendar, is a lunisolar calendar. And so something like 6 out of every 13 years has 13 months in it. And it doesn't keep the two calendars precisely aligned, but it keeps them close enough for what you need. It works out so that you're not having harvest in the middle of February, which can happen if the months are slipping all the time. We do the same thing with days and seconds. We stick in leap seconds to make up of slight differences in time. And of course, leap days, we have our standard leap year when we insert 1 day. Anybody know what date is inserted?
Isn't it every 100 years?
No, it's done every 4 years.
No, I thought you were asking which year that we lose a leap year.
Yeah, when it's evenly divided by 100, I believe, we don't do it. But anyone know what day we add?
February 29.
Actually, it's February 23rd. Because the Romans came up with this idea. They knew they were losing time. And so they wanted to add a year, but they didn't want it to be at the end of their year, which was the last day of February. And so they added it a week before. And by law, anything done on February 23rd on a leap year, whether it was February 23rd or the old February 24th, which is now still the 23rd, would have considered to be done on February 23rd. That's the 6th day before the end of the month, which they called sextus. And so another term for a leap year is a bisextile year, a term that's not nearly as exciting as it sounds. Now I'm going to give you an overview of texts just to give you an idea of the range of texts that we have from ancient Babylon that deal with astronomy. We have over 5,000 of these. from roughly 2500 down to the 1st century CE. Akkadian is the language that has been used the longest for record keeping. It was used into the 1st century CE, and so it gives it about 2600 years. One of the earliest type of astronomical texts we have is called 3 stars each. Babylonian texts, or ancient Near Eastern texts in general, are often named by the first words in the text, and this one's called 3 stars each, comes from the 12th century, and they imagine 3 paths across the sky. We don't know where these paths come from, but they may be at the angles that the sun takes at different time of the year. But one was above 17 degrees, one was between plus and minus 17 degrees, and the other one was south of 17 degrees, and these were called Ea, Anu, and Enlil, who were 3 of the gods. And these were their paths. And this, for each month of the year, 3 stars each will give you a star that is up in each of the paths there. So it's a way of telling, oh, Cyrus is up. Must be June.
What is your 17 degrees that you mentioned? Is that an altitude angle from the horizon?
No, that's the galactic coordinate system.
They were using the galactic system.
No, they weren't. We've just noticed that all the stars in Ea are below negative 17 degrees. All the ones in Anu are between 17 and plus 17, and all the ones those are our coordinates, not theirs.
That is very
Yep. Another set of texts are what are known as astrolabes or astrolabes. These are maps of the heavens, and this is a reconstructed one. The parts that are clear are the parts that have been reconstructed. And the parts with text on them are the original astrolabe. And these, you'll notice they're divided, in this case, into 8 slices for different directions. And it would tell you, here you can see 3 of the stars that they're pointing out, and there's another star up there. And so you can look at them, and you'd stand there and hold them up to the sky and wish that you had a headlamp. And try and pick out the areas where those particular stars were. Here's another example of an astrolabe. So you can start to see the cones in the writing here. We're getting a bit bigger ones. The most important astronomical text is called Mul Appin. And it takes its name from the first 2 words of the text. And these are the signs for Mul Appin. This sign here is Mul, and it comprises 3 of the same sign. This sign by itself, with the vertical, the horizontal, and the diagonals, is the Sumerian word dinger and the Mesopotamian word ilum, which means God. So if you have one of these before a word, you would expect the next word to be a god, as we'll see in just a minute. Put 3 of them together, you've got a constellation, and that's what Mul means. They used, Mul was a Sumerian word. Kakabtu was the Babylonian, Akkadian word for stars. And they used this term not just for stars, but for pretty much anything in the heavens. For planets, for comets, for constellations as well. I mean, you got a grouping of stars here, so you can see how it mean constellation. And if you have Mul, 2 of these symbols next to each other, that's actually their name for the Pleiades. In other words, a constellation of stars, of a bunch of tightly packed stars like that. This word is Appin. And Appin refers to, it's the Akkadian word for plow, and that was the name of the first constellation that they describe, probably in the area of Triangulum. Triangulum is the plow, and then the handle goes up to Gamma Andromedae. Mul Appin was written sometime in the early 1st millennium. We don't know exactly when, but it appears to have drawn on earlier texts. And it is primarily a star catalog. The first section, again, as with 3 stars each, divides the stars into 3 different paths and gives 3 stars in each combination, in each constellation. We are given the dates of the heliacal rising. Heliacal rising is the first time when a star is visible above the horizon in the east as it's coming up. And for this, as you can imagine, doing any kind of astronomy with a calendar where you can randomly stick in months is a bit difficult. I mean, imagine if your stopwatch for timing something suddenly inserted an hour for no reason. So for listing these, they use an idealized 12-month calendar that had 30 days in it, which gets you much closer to the 364. It then also has a section where it talks about pairs of stars where one of them is setting in the west right as the other one is rising in the east. And then it lists stars that are found in the ecliptic. And this was a remarkable text. We have it in many, many versions. And we also have references to this text in other texts. One of the things it has at the end of the text, and it only takes up 2 tablets, possibly sometimes 3. At the end, it has mathematical calculations for determining where Jupiter will be, where all the planets will be, for determining the next rise of the moon, and so forth. And we have letters that were written. This is also how you wrote a letter. It's a difficult way to write a letter, but we have letters that were sent to people, and people had written in and requested, I need to know how to calculate the position of Jupiter. And so they'll just take that little bit out of Mulapin. But they'll have to say in the text, this comes from Mulapin, and give us that text. So we have all sorts of references to this. It seems to have become a very standardized kind of reference work for Babylonian astronomers.
How many tablets are in Mulapin?
How many tablets? We have a lot of tablets that contain Mulapin. One complete text of it would normally be about 2 tablets. And you see it was written in the 2 columns there. You should have 2 with 2 columns. It could imaginably spill over onto a third. We've got some that are on very large single tablets.
The size of the table that you showed us, the true size.
Of this tablet, that would be about this big, probably.
So it's so concise.
Yeah, it's very concise. I mean, that's a headache to read.
Is this all out one complete text, even though it's only 2 tablets long?
Yeah, it seems to be one complete text.
And it lists all the stars that they thought were important enough to include in the catalog.
Yep,
Has it been translated into any modern languages?
it has been. Yep. The first scholarly edition was published in 1989. A new one was published just about 10 years ago with some even more text that they had discovered since then.
What's the new stuff they discover if it's complete as is?
Well, they didn't discover new sections of it. They discovered new texts that had the same section, and sometimes those may have slightly different readings. And so we're always trying to reconstruct what we call the text, meaning the original text as it was written, because we don't have the original text as it was written. The next text that is of importance, and I'm going to discuss this one at length, or at least one tablet from it, is Enuma Anu Enlil. And that's Enuma Anu Enlil in Babylonian. This is the word Enuma. Then you recognize this sign. This is the word for God, and it's a determinative on this side. So you know that this word's going to be a god, and that's Anu, who was one of the gods. Then we have another god determinative, and then this is 3 signs, En, Li, Il. This is the god Enlil here. And again, this is the first name, the first line of the text, Enuma Anu Enlil, oftentimes just called EAE, for obvious reasons, because it's long and cumbersome. Enuma Anu Enlil means when the gods Anu and Enlil, and then the text goes on from there, did something. This was discovered at Nineveh, which was the last capital of the Assyrian Empire. It was the capital in the Neo-Assyrian period. And it was destroyed by the Babylonians in 612 BCE and had quite a library. This is from the library of Ashurbanipal. And this too is this is one of the tablets from EAE. And this is a compilation of texts over many centuries, some going back at least as far as 1600 BCE. And it's primarily a set of omens that are related to things that happen in the sky or meteorological ways. This has happened, therefore kings are going to go to war. This has happened, you know, it's kind of a red sky at night, sailor's delight kind of thing, you know. Jupiter encounters Saturn, you know, whatever rhymes with that. Yes?
Did they distinguish planets and things from stars?
They did, but they didn't use a different word for them. And the names they gave the planets were all related to the gods. Marduk is Jupiter, Ishtar is Venus, and so forth. Every entry has a protasis and an apodosis. And if you're not familiar with omens, the protasis is if Venus rises on the 8th day of the month for the first time in the west. The apodosis is then we will have good harvests. And I think the protasis is this is what happened. The apodosis is this is what is going to happen after that. And I'll show you something from this in a minute. The contents of the tablet, they contain lunar phenomena and lunar eclipses, solar phenomena and solar eclipses, weather phenomena, and then 56 through 68 are all about stars and planets. And there you can see the breakdown between them. And then one last tablet I wanted to talk about. This is a tablet that dates to September 164 BCE. It is one of the last tablets that records any astronomical observations from ancient Babylon. And it actually records the first recorded appearance of Halley's Comet. And it's not just recording the appearance, they actually recorded observations of it. It appeared for the first time on September 23rd, 164, and disappeared. The last visibility was on September 29, 1964. Now, they didn't give the dates in that term. They gave theirs. We're able to work it out going back from here. This one is in the British Museum, and that one's, you know, something like that right there.
So pocket-sized.
Yeah, it was the astronomer's pocket atlas. Yeah.
Question?
Yes.
Was there an official state of astronomy department that was reporting these
No.
things?
No.
Tell us
I mean, it was generally done, we think, by priests. Because anything to do with omens, the priests are going to want to know about.
more than one location, then.
In multiple locations, yeah.
Interesting.
Yeah. One astrophysicist has done a retrogression of the star rising and setting times in Mul Appen, and he thinks they best fit a latitude in Assyria, about middle Assyria, between the years something like 1400 to 1300. How accurate that is, we have no way of knowing. I mean, I can use the AstroPi library to retroject when we think Venus was visible in 1600, but we have no way of checking whether that's true or not. And it's
Another quick question. There
Sure.
was sort of a dark ages in the Near East between 1200 BCE and 800 BCE.
the Kassite period.
Is there a gap in the astrological observations in that period?
Yeah, I mean, some of them may have continued to be carried on and were later incorporated into Mul Appen or Inama Anu Enlil, but we don't know. I don't know the ones that we have from that period. I'm sure we have some somewhere and could be dated,
Somebody was still reporting,
probably.
even though it was a pretty rough period to be doing it in.
Yeah.
Well, you do what you have to do to get by.
Government was gone, their budgets
Yeah.
were gone.
There's still a bunch of astronomers like us hanging out, wishing we had something to do. So. Yes?
So was this like, the reason why they stopped, was it because their society fell apart, or they just couldn't use?
Yeah, the period of the Dark Ages is well known throughout all the way down from the Aegean into Egypt. I mean, calling them Dark Ages is a bit of a misnomer. There was still stuff going on. There was a lot of stuff going on. It was a period of collapse in both the Egyptian and Mesopotamian worlds. And they had always controlled the land in between them. I mean, that's all the land of Israel has going for it, is that it's a nice place to get other places. I mean, it's kind of the New Jersey of the ancient Near East.
There were lots of tablets. Have they all been read, or are there large numbers?
There's large numbers that still haven't, simply because there's such few scholars in this field, and translating a tablet is an onerous task. Even translating it long after a bunch of other people have read it still comes out to be an onerous task. It's why my main focus of study was Egyptology, because hieroglyphics are a heck of a lot easier to read. Although I eventually settled on Hebrew because I'm left-handed, and writing right to left, this is the first language I didn't smear across the page as I wrote it.
I was going to say, the things you've been showing us are left to right.
Yeah.
Right to left. Is that surprising for a Semitic language?
No, you can get these right to left. You can get these left to right, right to left, top to bottom. There was no standardized way in writing them. I'm presenting the signs left to right just because that's our convention. But they could write them, and the same for hieroglyphics. And the way you can tell which way to read hieroglyphics is you're always reading into the animals' faces. If the duck is facing that way, you read from that side. So, and remember, it's owl before reed leaf, except after quail. Yes.
You showed the clay disc.
Yes.
You called it an
Astrolabe.
How did that merge into the navigation instrument, the astrolabe,
Well, it's just because they have the same usage.
with all the angles and symbols
Yeah.
around it?
This is just the best one you can make if clay's your only material you can work with. Well, what can be said about Babylonian astronomy as a whole? What did they know about the universe? And why did they do this? And their primary motivations, first, was to keep track of time for a calendar, because if you don't have a calendar, the government can't levy taxes. To know when to plant, when to pluck, all that. They also wanted them because they wanted to understand the oracles. And they think a lot of the oracles come about by having an idealized version, like this idealized 12-month calendar of 30 days. That's what life should be like. Anything that deviates from that. If Venus comes up on the 7th when it was supposed to come up on the 8th, that's weird. That's going to be a bad omen. And we know they thought along these lines because they also practiced what is known as heptoscopy. If you thought having your palm read was bad, heptoscopy is the practice of divination by use of animal livers. That's the hepta part of it. And we actually have clay livers where it will say, if this nub over here is missing, it means such and such. If this over here is turned brown, that's a bad sign. Get that checked out if it's a problem. And so that may be why they had the oracle, kept track of things, was to understand what was normal and what was abnormal. But also they simply wanted to understand the heavens, as we do. They look up, they see these things, they're going, what's that thing moving across the sky? Why does it keep going like that? Mercury's in retrograde. Should I take responsibility for my actions? And they also formed the foundation for much of modern astronomy. The names of constellations, some of them, or at least the identification of constellations, the bull, Taurus the bull, was called Apu the bull in ancient times. They already had a scorpion. sign, and they also had the goatfish, the Capricorn, who was a demon. I don't know how you come up with the idea of a goatfish demon. But one way to tell it's a celestial or a mythical, fantastic creature is because it's a mix. You always get these mix between two different types of animals. You know, think Minotaur or the Seraphim. The names of some stars come from this period, and the rest come from the Middle East during the Middle Ages. If you look up and you see a star that has AL at the beginning of the name, that's going to be named by Arabic astronomers. Words like altitude, azimuth, all of these are Arabic terms as well. They also used, and if you think translating text was hard, try doing math in a sexagesimal system. It was a base 60 counting system. And there's a way to do that with your hand that involves counting all the knuckles so that you're going up like this. But the fact that they were in base 60 is the reason we still have 60 minutes in an hour and 60 seconds in a minute and 360, 6 times 60 degrees in a circle. And also, they wanted to understand the heavens. They kept track of the synodic period of planets, the time it takes for a planet to come back to the same space in the sky with respect to Earth. They recognized the varying altitude of the sun throughout the year, and Mul-Appin has a section that keep track of the length of a shadow cast by a standard length rod during different times of the year. They kept track in the variation of the length of days and in the lengths of months, although they weren't as scientific as they could have been here, because, you know, they want to impose order on the universe, and so everything has to be nice even numbers, or nice round numbers. So they assumed that the night in the middle of winter was twice as long as the daylight. In the fall and spring, each of them were equal. And then in the summer, the days were twice as long as the nights, which is not quite the ratio we're looking for. They also knew about the variation in the lengths of months, simply because of the different number of days when the new moon would appear. And they also wanted to organize the heavens. I learned a new term in researching this, which is uranology, which is not the study of urine, Uranus, as in Uranus. Uranology is the mapping of the heavens, and they wanted to keep track of all the stars in their position and learn where things were in the sky. And they, as I said, put them in these paths of Ea, Anu, and Enlil. And on this map, I've mapped the stars that are listed and the ones that we know that we have a fairly decent identification for. I mean, if they say the name of this star is the goat, you know, we have to find something else that's an astrolabe or something that says the goat is here in this location. If not, we're taking educated guesses. So the orange at the bottom, the lower than 17 degrees is Ea. The red is Anu that runs across the ecliptic. And then the Enlil is the top, the yellow ones up there. But you can't always take these reconstructions at face value. This is a reconstruction in the Stellarium program. I'm sure most of us have used Stellarium online. It's a wonderful astronomy program. And if you download the app that they have, it will show you the constellations from different cultures, which is great. Except I'm not sure how accurate this one is. This one everyone pretty much agrees on. This is called the Field. And it's the Great Square of Pegasus. Right? The Plough, as in Mul-Appin, the first one, it's generally considered to be the trapezium, which is down here and going up to a star in Andromeda. like that. So I'm not sure how much these are. And notice that they called, what we call the Big Dipper was the wagon of heaven, which to be fair, it looks as much like a wagon as it does like a dipper.
Did you say that was trapezium?
Triangulum, sorry. Triangulum, not trapezium.
The apple stellarium, though.
Yes, stellarium. Yeah. So, what do the Mesopotamians know about the heaven? Well, for one thing, they realized that inferior planets in the morning were the same bodies as the inferior planets in the evening. They knew that that light that shows up sometimes at night and is very bright is the same as that one that shows up in the morning and is very bright. They knew the one that was dim that was there sometimes at night and showed up again somewhere in the morning. Yes?
Can I make a comment on that?
Sure.
You read, and of course they knew that.
Yep.
Smart people. But
Yeah.
you read, like, the myth that we have in today's culture, from what I've noticed, they say that the ancient cultures did not, and they didn't know that.
Right.
And it's so annoying when I hear that. I'm like, of course they knew that.
Well,
It's so nice to hear.
the Greeks are generally credited with discovering it somewhere around 300 or 400, I believe. An astronomer recognized that they were the same, and this is at least as far back as 1600. The Babylonians knew about it. They also recognized that some stars were variable. In particular, they noticed the brightening and dimming of Betelgeuse, which, by the way, is another Arabic name. It comes from the word Yad al-Basel, that means the arm of the hunter, because it's up in the right shoulder of Orion, except that it would be Yad al-Basel, not Bad al-Jazal. Yeah, hand. Yeah, in modern Arabic. But the Y and the B are written very similar. The B just has a dot under it. And somewhere in the Middle Ages, when Europeans were translating these texts from Arabic astronomers, they made a mistake, so we get Betelgeuse. And our culture is richer for it. And Michael Keaton is richer for it. So, they also recognized that stars could be of different colors. And they would list stars of varying colors. Red, white, and blue it's generally acknowledged that there are no green stars, but they saw one. The reason there's no green stars is that a star that's green is giving out most of its light in the middle of the spectrum. But of course, it's giving out light across the entire spectrum, so the red and blue get mixed in it, so they appear white to us. But they thought they saw one that was green, and they also noticed that the stars changed colors as they were setting in the evening because of the different density of the atmosphere. They were also able to make predictions based on calculations for the positions of the planets. They could predict lunar eclipses as well. They often also recognize the difference in the sun's altitude at different times of year. Now, I want to focus on one particular tablet from Enuma Anu Enlil, tablet 36, and it's known as the Venus tablet of Amitsaduka. 63. Did I say 36? Yeah. Dyslexia is fun. Or enough.
Well, when you're reading from right to left, up and down.
Yeah, it's... Forget which language I'm reading there. Now, the problem we're going to be addressing here is one of chronology in the ancient world. We want to know the date on which something happened. Oh, something happened today. We look at our calendar. Oh, it's June 18th, 2025. But we can only do that because we all have an agreed upon calendar and we all have an agreed upon starting date, which was January 1st, 1 CE, because people thought that was when Jesus had been born. We're actually off by 4 years. Jesus was probably born about 4 years before that, which leads to the odd statement, Jesus was born 4 years before Christ. But they couldn't just do that in the ancient world. Everything is a relative chronology. And so they would list the names of the kings and how many years that king ruled, and any event that happened would be dated by the king and his regnal year. So they would say in the 13th year of Sin Mubalit, Akkad went to war with Babylon. Keep in mind, Babylon is a city and a region. So, and this gives us a relative chronology. I can tell you the first year of Sumu-La'el is 14 years after the first year of Sumu-Abum, but I can't tell you what year that was on our calendar. What we need in order to do that is an anchor. We need to, if we can peg 1 year of one king, then we can start going back and forth and calculating from there to get those.
But how do we know? Are they using the solar years here, or like
Well, they're using their calendar.
the lunisolar calendar? So they're always, so 14 is referring to the solar year.
Yeah.
Question.
Yes.
Very often, if there was a king who started a war and was defeated, his name was obliterated from the records. So how do we know that we don't have, they're missing?
We don't have any evidence of that being done in the ancient world.
Oh,
Yeah. I mean, and if it was, they hid their tracks pretty well. You know. So it would be nice if we had an anchor for some of these. And this is where the Venus tablet of Ammisaduqa comes in. Venus tablet 63 records observations. I don't just mean, hey, there's Venus, but precise observations of its heliacal rising and setting in both the east and the west for all 21 years of his reign. And so if we can match that up with what we know about the rising and setting of Venus at that time, and determine when his first year was, we can then get an absolute chronology for the rest of these kings as well. Now, most of you understand this, but I like making little charts and things. Venus is an inferior planet. It never gets more than 46 degrees away from the sun because it's closer to the sun than we are. And there are 8 major points in its orbit, and these are points as they relate to the position of the Earth. The blue dot is the Earth, the orange dot is Venus, and the yellow one is the sun, obviously. I'm not very creative. So we have our first point, which is inferior conjunction. We can't see Mercury when it's in inferior conjunction, and the ancients couldn't either, because it's between us and the sun. We then have what is known as the first heliacal rising in the morning, which is the first time that it's visible coming up out of the sunlight in the east. We then have the greatest eastern elongation, and then the heliacal setting in the morning. This is the last time it's visible, because it's moving below the horizon. We then have superior conjunction, and then a heliacal rising in the west, the greatest western elongation, and the heliacal setting in the east. And it's these heliacal rising and settings that are recorded in the Venus tablet. And here's just, in case you're not familiar with, this is what Venus looks like. You get the rising, goes up, greatest elongation, turns around, comes back down. And when it's in the west, it does the same thing over on that side. And you also need to understand something about the Venus cycles. It's well known in astronomy today that Venus and Earth are in a 5-to-8 ratio in their orbits. For every 5 orbits of the Earth, Venus goes around the sun 8 times. Okay? And so, if you track out this cycle and want to see it as it relates to Venus and Earth with the particular direction toward the stars, then you're going to, these are the ones that are going to come out. The synodic period of Venus is 583.92 days, roughly 1.6 years. And after 5 synodic periods, they return to the same place. So after they've done 5 of these 583-day cycles, they return to their same place with respect to the stars. And the complete cycle takes roughly 29 and 19.5 days. So as they're orbiting, Venus orbits faster, being close to the sun, as Newton tells us. So they'll catch up with each other after 1.6 years, and they'll keep going around. And every 1.6 years, they'll catch up again, and we'll have an inferior conjunction of Venus.
Maybe 0.625 years for Venus then.
And then finally, after those 8 years, it's going to come back to the same position with respect to the background stars when it reaches that top line again. And for us, that's what we think of. We're used to this nice 8-year cycle. Makes us very happy. There's a problem, however. This works if you're using a solar calendar. If you're using a lunisolar calendar, well, the solar years are 2,922 days. 99 lunar months is 2,923.5 days. So you're getting a 1.5 day offset. So after those 8 years, it's not going to be the beginning of the month, it's going to be the second day of the month. And so if you were an ancient Babylonian looking for it to come back to the same point, it's going to do that roughly every 56 or 64 years. Because 7 or 8 cycles, 7 times 4 is 28, and so that's almost giving you another month. And 8 is giving you more than that. So about every 56 or 64 years, you're going to get the calendar lining up with the solar cycles, once again, if you're using a lunisolar calendar. And on the basis of comparing these rising and setting times, they should only fit one period within that time, simply because of the fact that the moon is going to be different each time. There should only be one time period, one particular set of solar cycles where it will match exactly to the observations that we have in the Venus tablet. And on the basis of this, they've proposed 3 chronologies. One places year 21 of Ammisaduqa in 1702, the next one in either 1746 or 1738, and the low in 1582. And keep in mind what this does is if you're shifting one king by that amount, everybody else gets shifted as well. And we're looking at slightly more than 200 years in difference between that. So if we go with the high chronology, we've got to find 200 more years of history that we're kind of missing. Yep.
It's surprising that they couldn't just find another tablet that talks about the eclipse or something and then
Yep. That would have been nice.
maybe one of the untranslated tablets.
It could be. Maybe it'll pop up someday. We always hope. And most have tended to go with the high chronology. That's been the assumption because that seems to be the best fit. And I want to talk about how we go about fitting the data in the tablets to the astronomical cycle. So we have a little more than 2.5 years of observations, 2.5 8-year cycles over those 21 years. So we're trying to locate that 2.5 years should fit precisely somewhere within a 56 or 64 year period. We should be able to find one that matches. And we can calculate the heliacal risings and settings of Venus in ancient times. It was originally done by hand with ephemerides and now done by computer. And I've calculated some of the rising and setting times for Venus in that period. One problem is we don't know if we're accurate or not. We need to get a TARDIS and go back and check when did Venus actually rise on such and such a date. And let me just give you some examples of some of the omens so you know what kind of critter we're dealing with here. We have one omen, which records a heliacal setting in the west and heliacal rising in the east. So this goes through an inferior conjunction. It says, in month 11, day 15, Venus disappeared in the west. For 3 days in the sky, it stayed away, and in month 11, day 18, Venus became visible in the east. This means springs will open, the god Adab will bring his rain, and Ea, the god Ea, will bring his floods, and kings will send messages of reconciliation to king. So all in all, a fairly good omen with this one. The second one is a heliacal setting in the east, a heliacal rising in the west, so including a superior conjunction. In month 8, day 11, Venus disappeared in the east. For 2 months and 8 days in the sky, it stayed away. And in month 10, day 19, Venus became visible in the west. The harvest of the land will prosper. So good news, everyone. Now, there are, of course, some problems with the data, as we would expect with any data set collected in the past. They had some limitations that we're able to overcome. It's because, we write something down, we publish it, it's in a set form for all to see, right? Tablets survive really, really well, but they can be destroyed. If you smash them intentionally, they get destroyed. And they can also be dropped and chipped. You lose certain readings. And also they have to be copied over and over again. And whenever you're copying something, looking here, then writing down what you saw, look back, write what you saw, mistakes can be made. You put one little read impression at the wrong angle, and suddenly Venus is on the other side of the sky. So we have to deal with the fact that some probably have been corrupted along the way. Some of the given dates are simply not possible. It will say that, Venus disappeared in the morning and reappeared, 9 months later, which we know that didn't happen.
So I was wondering on that, the 3-day thing, like when Venus has the inferior conjunction, it's like 10 days or something, or?
It was very short. It was just 3 days on this one. It can be as short as that, but yeah.
Like it must be how thin their skies are, because like in this.
Well, yeah, they didn't have to deal with any light pollution or anything, and not really any mountains on the horizon either. So, for their lunar calculations, they assumed that if the sun didn't show up on the 39th day, even if, say, it was cloudy the next night, they assumed it did show up tonight, because that one was common enough that they could say, yeah, it had to have shown up tonight, even if we didn't see it. We also have, I mentioned before, there were some new tablets that are found. Sometimes if we have two tablets that are the same text, they can have different readings on them. One will say it rose on the 8th day, the next one will say it rose on the 11th. And sometimes we can tell which one is earlier and which one is a corruption. Other times we can't. And you can pick which readings you prefer to get the calculations you prefer, but that's somewhat begging the question and special pleading. So we also, and this is one of the big ones, we don't know when they stuck in intercalary months. In any of these calendars where it showed up now, it disappeared now, it showed up 3 months later. Was that 3 months or with or without an intercalary month? So some of them could be off. And like I say, these intercalary months, you get them in slightly less than 50% of the years in order to keep a calendar like that in sync. And so what people who do these kind of calculations have told us is that the high chronology has the best fit and the middle chronology has the worst fit. And take that for what it's worth.
What's the criteria for fit?
They compare how far off the data in the tablets are from our calculated data. And one where you have every day off by a half a day is better than one where several of them are off by 5 or 6 days. But all of our fits have a high number of errors, for whatever reason, ones that were corrupted, some readings that we don't know about.
All of Babylonia know to add one intercalarian month.
Yes.
In a given year. That's
Yes.
a national thing.
Yeah, it was done by the official government and would announce when it was. Also, the data is fairly noisy. It tends to jump around and doesn't have the nice smooth fit that we would expect it to. And if you go within an 8-year cycle, you can often find multiple good fits, which is another problem. So we could fit it to one 8-year cycle, but be in the wrong 64-year cycle or 56-year cycle. Also, it does not, as you mentioned, take other types of observations into account. We do have other observations that we've got Halley's Comet. And if someone said Halley's Comet had done this while Venus was setting in the west, boom, we've got a double whammy that tells us exactly where it is. But unfortunately, we rarely get those. We'll get them with lunar eclipses, I would suspect. And there are some glimpses of hope. What you see here is the island, or what's left of it, of Thera. It used to be a lot bigger. It was a volcano. You can see what's left of the caldera there. It erupted somewhere around 1650 to 1500 BCE. And so a while after that, we start seeing, one of the nice things about pumice is it kind of floats. And so it drifts all the way to the edges of the Mediterranean. And we start seeing in Egyptian burials, we start seeing pumice artifacts showing up in there. Also, an eruption this big clouds the sky for several years. Cloudy skies means trees don't grow as well. And therefore, when we find an ancient piece of wood that's been carbonized, we can slice it and look at the rings. It's a process known as dendrochronology. Look at the rings and match them up with other pieces of lumber we know from other sites. And so we can say, this tree shows 3 years in a row with almost no growth because it's the thickness of the bark within the ring. This one had one with almost no growth, and therefore this must have been during the reign of Thera, and then we can take from there, well, this building was built here, so that has to be X number of years after the eruption of Thera, and so that gives us another outside way to kind of corroborate the data. And there may be other, as I said, other astronomical data may provide a better means. Yes?
The Earth doesn't rotate, the axis of rotation changes. So is that taken into account? Does that affect?
Well, the axis doesn't change, but the axis processes around there.
Well, that's taken into account.
Yeah, as I mentioned at the beginning, the vernal equinox was about 51 degrees east of where it is now. And so when they're talking about their zodiac, they're going to start in that other constellation. But that's something that changes so slowly that over a 56-year period, you're not going to see a difference, unfortunately. I wish we could. That'd be nice. So, any questions? It depends on how well it's preserved. I mean, just because we find carbon doesn't mean we can date it. It has to be a pretty good sample. And if it was close enough to have ash fallout, there may have just been a lot of particulate matter in the sky, because this is in Greece, or actually in I guess the Aegean. But it did. One minute there was a mountain there, and the next minute there wasn't. All of these used to be one island with a big cone in the middle, and then that went away. So, and what they think was even larger eruption than what's the one in the Pacific? Krakatoa. When I was doing archaeology in Israel, we were in a town that we knew had been destroyed by Nebuchadnezzar of the Neo-Babylonian Empire in 604 BCE. So we came down, we found a nice ash layer that just covered everything because the entire city had been burnt down. You know, with something like an eruption of this going all the way over to Babylon, you're not going to get the kind of thick layers that we see a lot of times closer in.
Wood or something.
Yep. And the wood has to have been carbonized because otherwise it's not going to survive. Well, that was right at the foot of the mountain. So we're not going to get those. There is thousands of miles to the west of Babylon. So I mean, it would be really nice if you know, it's like the old joke that if you dig up a coin dated to 63 BCE, you know, what layer was that, when was that coin made? Obviously in minor times when somebody didn't know that they didn't know it was BCE back then. You know, there's they didn't. That would have been nice too, yeah. There's a lot of woulda, coulda, shouldas. But I mean, if they just all had a big symposium and said, okay, remember that big meteorite we saw 10 years ago? Let's call that year 1 and we'll date everything from there. Or, you know, but unfortunately that didn't. And this is a problem that's common to all archaeology. You get a lot of good relative chronology. I mean, if something's on top of something else, it came afterward.
Something online about a recent dig, and they found some stuff that's more than 10 to 15,000 years old.
Well, there was a recent one down in Chattanooga, near Chickamauga, that they discovered a Viking artifact that was in a strata long before we know Vikings had any contact in that area. And of course, but then you've got to look at other explanations. More than likely, this was a trade artifact that came through extensive indigenous trade routes as a status item, because, you know, this was made by the Vikings. This thing's metal. They were still in the Bronze Age. That's the best they could do. And so having an iron item would have been a high status item, so this could have traded hands quite a bit. It doesn't mean that there were Vikings in Chattanooga. You know. So, any other questions? Yes, sir.
Does anyone compare this knowledge of astronomy with other civilizations, like the Chinese?
I'm sure some people have, but it's just the question of if they kept records that are comparable. You know, if they kept records of Jupiter rising and setting, that's not going to help us. It might help Chinese scholars date some ancient things, but.
And is there any evidence that they thought of the Earth as being just flat?
Not that I know of. I mean, although, you know, for most of human history, we've thought it was round. So, I mean, the Greeks knew it.
Plato knew it.
Yeah, they knew it even before Plato. They were back to, you know, 500 or 600 BCE. They knew it was round. Eratosthenes, was it, that calculated the diameter? Eratosthenes.
Have you read Clyde Hostetter's Star Trek to Hawaii?
I have not.
Or not, haven't heard of it. Would you say a little more about, we had earlier mentioned that some people Egyptologists may disagree with the earliest writing. This was dated 3300 BCE.
Yeah.
What is the creative on the earliest narrative of this?
Well, that's the issue. I mean, I said this is dated to around 3300 BCE. We don't have a good solid date. And that's the problem. We don't have a good solid date in Mesopotamia. We don't have a good solid date in Egypt. So both of them are making guesses, and each wants to claim that it's theirs, and some of us in between don't care.
So there are people who feel very strongly that Egypt.
They do. Any other questions? All right, well, thank you all very much.
Coffee mug here.
Oh, can never have too many coffee mugs.
Yeah, hang on.
Oh,
So, I don't know, did anyone have any Astor photos they wanted to show? I've pretty much come up dry the last month because there's been so much cloudy weather. So I just threw in two that I took back in May, which actually I think I showed at last month's meeting. NGC 4449 is an irregular Magellanic type galaxy in the constellation Canis Venatici. It's about 13 million light years away. And so it has kind of this unusual structure for a galaxy that I don't think I've ever seen anything quite like that before. But it was interesting to image it. And then, of course, Bode's galaxy M81 was in a good position last month. And it's a grand design spiral galaxy about 12 million light years away in Ursa Major. Yeah.
12 million light years, including the intercalary light years? Is that what you
Well, you can figure that out.
Have a light month every 4 years. Speaking of which, you added an intercalculary day to the date. It was actually May 17th.
Okay, yeah. This was maybe the day I processed it. And then I looked at what I had last year at this time, and I was doing the Sombrero galaxy then. So it's in constellation Virgo, and quite a bit further, closer than the other two galaxies. I'm sorry. It's 105,000 light years across, but 31 million light years away. So, and it has a large black hole in its center. So that's really all I had to show. And I think, David, you wanted to say some things about Tau. So.
Okay, guys, and ladies, no offense, okay. I want to tell you some of the things that are going on. And I just thought I'd go over it because sometimes we mention them and sometimes we don't. So for those of you that are new, Orion does a lot of its things as far as viewing away from Oak Ridge. Oak Ridge is convenient, city is convenient. The skies are, Tennessee skies have moisture and dust and so forth. With some light pollution, they're useless for many things. So if you get away from the city, it's nicer. There are places like Big South Fork, Lily Bluff. One good place is Tamaki Island Observatory, which is only about 35 or 40 minutes west. And we try to get up there when things happen, and I'll tell you about some of those. We also try to get up there on the first and third Saturdays for public stargazes. So is the audio coming through okay? Let me know. And sometimes I zoom ahead and talk too fast or mumble. Sometimes they compensate, but often not. Okay, Tamaki Island Observatory is where we do our astronomy things. It's where we teach. It's where we have events. So our events, I thought I'd go through some of them. The first two are easy to go through. Public meetings are the third Wednesdays here. The public's welcome. We have programs sometimes for members, sometimes from guests. Projects, they vary all over. Sometimes student projects, they can be interesting. Radio astronomy, building things, models, sundials, radio astronomy, whatever. Lately, they've been working on our Meade telescope, which one wants adventures. One wants things that don't work, but one also wants to be able to fix them. The Meade telescope has been creative in some of the adventures. So Rob, especially Rob and especially Ted, but I've been doing some of it, and we've been trying to improve it. So when we say go to a place in the sky, it goes to that place in the sky. It usually works. And there's a lot of things. We've done some updates to the electronics and so forth. And then we get into the fun stuff, which I thought I'd go over a little bit more and show you. We have our public stargazes at the observatory, and they start out slow. Sometimes there are a lot of people, but it's quite a bit of fun. And we have in the small dome, which actually glows, it has zinc sulfide in it, so it absorbs energy from sunlight, and then it gives it back through the night. It's interesting. It gets dimmer and dimmer, but the night can get dimmer also. So it's quite interesting. We also have a nice refracting telescope, and people bring their own scopes, which span a huge range. It's just fun to see what people can bring out and what can be done with them. So there's Don, President Don, in the lower left, and he actually brought his drone out to the last stargaze, which explains this photo. What is it, DJI 4?
4K movie.
4 mini?
Yeah, 4K.
It's very impressive.
Saturday's good, I'll try to bring it out.
Yeah, bring it out, and yeah, that'll be interesting and very good. So it's sometimes a beautiful place for sunsets. This is Ted's setup, and I don't understand Ted. It's a beautiful place on the horizon, and he's got a graphic. I was looking at that was interesting. But Ted's setup is one of the best, maybe the best setup that people are using for occultations, and the occultations are really quite fascinating. We have our public events in the classroom, and what you're seeing here is some of the things in the classroom, and then over on the right, that's Rob in the glow dome, and sitting there with the Meade telescope, which is of course a nice telescope. It often goes to where we want it to go, and it's big. Bigger is better in that it collects more light. So light buckets are good for dim objects. And I believe this is Ted's screen looking at an asteroid and a distant star.
Yeah, that's Irene.
This is Irene. So
After the occultation, we all got to sing good night.
Irene, good night. Yeah, that was fun. We often break into musical things. Another thing we do, and this is kind of fun because it stresses us out to try to match up with the weather. But at each first quarter moon, we try to get together at the International Friendship Bell in Bissell Park in Oak Ridge. And glad you came. And so she brought along Ivy, I'll tell you. No, Ivy's not in these pictures. But anyway, it's fun to get together, start off a stargaze with a peal of the bell, and have an international friendship stargaze. So the next one will be the new moon in June, which is June 2nd. So anytime in that first week is probably good. And these have turned out to always have some surprises. That's Evie, right? Yeah, so Evie we always try to start out with one of the kid visitors giving the first strike. Sometimes the rest of us get involved too. That's what happened here. We couldn't resist it. Lately, I would say the last 2 months, we've looked into displays, and we've given some of our astrophotos, many by Don and Ted and Noah and John. We've given a couple to the college. I'd like to put up more, but we have to go gently with the college. Anyway, this is you're showing a photo on the right, and over on the left, over on the left is the display. Over the right is some of the happy crew. They're willing to serve you, fix your cars and all that. But it's a nice display, I think. You look at it more closely here, see some of the things in it. But this is at the public library. It's into its second month now, and we have just, for a few weeks, slightly different crew put up our second exhibit. If any of you have any questions, you can ask those.
Just curious, do we have any idea how long they're gonna let us keep it up there?
I haven't updated that. I think they will let us do it for another month. And they wanted to, but they didn't want to put it down on paper because if someone comes in and say, these crazy astronomy guys. Anyway, these things are good, are doing well. So a lot is happening. And if you have any questions, maybe we'll pass it along to Ted.
Okay, thank you, David, and I guess that closes out our meeting.